Hello everyone! This is a guide to show you how to configure two FTDVs or Firepower Threat Defense Virtual in a high availability or HA pair. They will be managed by Cisco FMC, which stands for Firewall Management Center. We'll set up basic web servers using the NGINX node in CML. We'll do some basic NAT, access control policies, and unified events management. Then we'll test our HA pair's failover capabilities. You will need a CML personal license because we are using FTDv and FMCv. Their images are only available in the paid version of CML, or if you have a support contract. I recommend your CML VM to have a minimum of 64 gig of RAM, 12 vCPUs, and 350 gig of storage. More is better. I am using a CML VM with 100 gig of RAM, 14 vCPUs, and 400 gig of storage. If you need to set up CML, I put a link to a video in the description. Let's get started. From our CML dashboard, click Add. Then we'll add our first node, which will be an external connector. Left-click it. On the Config tab, we'll change the connector selection to be System Bridge, meaning we will bridge our lab topology to our home network. We'll add another node, the unmanaged switch. Then we will right-click these and add a link between them. Just use the default ports, that's fine. Then something I wanted to do a little bit differently from lab number 1 is instead of using the Alpine Linux node as our web server, I wanted to try out the NGINX node, which is a Docker container, NGINX running inside a Docker container. So we will connect these by adding a link. Then left-click the NGINX node. We'll change the name to DMZ_server. Then in the config tab, we need to make some modifications. So we'll delete the # so that these configurations do take effect. We'll change it to Ethernet 0 as it is in our topology. And the IP address can't be 10.0.0.1 because that's my home router, so we'll change it to .130. This will make sure it comes up, and we'll give it a default route. We'll also add a route to the internal subnet that we will define later. Click Save. We'll add some annotations. Clone that. Now we can start up our nodes. To configure the NGINX node, you should right-click it, then select Console. Then up here, you'll need to right-click this title bar and change the serial to serial line 1. Serial line 0 doesn't let you do any changes because it's just a logging console. So we need to select serial line 1, then open console. And you'll see the host name is this random string of letters and numbers. Normally, I would like to change that, but changing it is a pretty complex process. So I'll just keep it as is, and you can see which server I'm configuring at this because of the title bar at the top here and in the topology. So we know this is DMZ server because of this label up here. Let's do a ping to the default gateway. That's successful. That's good. Let's ping out to the internet. Cloudflare DNS. That's also successful. That's great. We can also do a test to our web server because the NGINX nodes have the HTML page set up by default. So from my browser, I'll go to the IP address of the web server. And that's working. That's great. This is the default HTML page they have set up on those. Next, let's add some more annotations. So we'll clone this one and we'll call it DMZ. And it'll be that. And we'll make it a little larger and we'll move it over here and we'll scoot down. Then we will clone this, and for our internal subnet, it will be 192.168.1.0. Next, we can add our FTDVs in a high availability pair. So there will be 2 of these. And we will add a link to the data interface, not the management interface. The management interface will be on our internal subnet. So from the DMZ, we'll just have a connection to the data interface, which will be gig 00, and we'll mirror. This will be our active FTDV. This will be our standby. We will mirror the port connection on the standby. So we'll also use gig 00. Next, we'll add another unmanaged switch, but this time in our internal subnet. We will need to add data interfaces and management to our FTDVs. So we'll start with the management. Then we will add the data interfaces. We'll use gig 01 on each of them. Unfortunately, for some reason, CML doesn't always match up these links nice and pretty. Next, let's add an internal server. So this will be another NGINX node. We'll change the name to internal_server. Then we need to configure it. I will put this configuration in the description. So it will have an IP address of 192.168.1.130, and its default gateway will be .1.1. Click Save. And we will need an FMCv, which is somewhere in here. FMCv. This node is going to manage our FTDs. So this is a very heavyweight node. It requires minimum of 28 gig of RAM and 4 vCPUs, I think. Let me check. 4 vCPUs, as well as if you look at the documentation on Cisco's website, it says that it requires 250 gig of disk. Now, that's probably intended for a production environment. In a lab environment, you can probably get away with less than 250 gigabytes of storage. But I created a CML virtual machine that has 400 gigabytes of storage, just in case the FMCv really does require 250 gig. So it's best to over provision if you have the resources. Next, we'll also create our final node, which will be a Firefox node, or we could use the Chrome node. Let's try the Chrome node this time. In CML Lab 1, I used the Firefox node. Then we'll add our links to the internal server. FMCv only has this single port because it's only management. Then we'll add one more link to our Chrome node, which will be used for testing. Now we have all of our nodes set up. Let's do some more notations. So our outside interface will be 10.0.0.118. And we can duplicate or clone this. And on the standby, it will be .119. And we'll clone this. And the management IPs will be on the 192.168.1.0/24 subnet. And we'll duplicate this, clone it. The management for our standby will be 119. And then we'll clone this again. This will be our inside interface. It will be 192.168.1.1, and then the standby will be .2. Okay. Then we need an IP address for our FMCv. We will use .120, 192.168.1.120. That's good. Then the internal server will be using the same fourth octet as the DMZ server. So we'll make this 192.168.1.130. Then the Chrome client will be .200. Next, we'll add some rectangles to mark our DMZ zone and our internal zone. When you create an object, it's automatically assigned a layer. If you see that it's covering up your annotations like this, like my rectangle is, you can decrease it to -1, so it will be behind the annotations now. We'll change the background color to be this light pink color. We'll make the border dashed so we know it's a zone, and we'll make the corners rounded. That looks pretty good. We'll clone this for our internal subnet, and we'll change the color. We'll make it yellow is good. We should extend this down so that our Chrome browser is included in the internal subnet. Other than that, it looks pretty good. We can move these over a little bit so there's more space. Okay, then I also wanted to change the default page for the NGINX in the internal subnet. So let's start it up, and we can modify some files. So right click it, console in. We'll need to right click the title bar and change the serial to serial line 1 again. Open console. The index.html file is stored in this location. User share NGINX /html /index.html. So this is the default web page that comes with NGINX, with the NGINX node in CML. It says welcome to NGINX in the title, and it's got this header 1, welcome to NGINX. So we'll change some of this so it's distinguished from the DMZ server. We'll use VI. Or visual editor. Let's change the title to be welcome to NGINX again. And we'll change the header to be the same. Again. Okay. Then escape, WQ for right quit. Let's check that to see our changes using concatenate. And the title is changed and the header is changed. Let's do a test from our Chrome browser. First, we should start our unmanaged switch. Then left-click the Chrome browser before we boot it up. Select the Config tab. We need to modify its startup config. So we'll remove these pound signs. The interface is Ethernet 0, not Ethernet 1. The IP address is 192.168.1.200. And we'll also add a default gateway. Click Save. Then right-click it and select Start. Then right-click it, select VNC, open VNC, and we'll type in the IP address of our internal server. And that's great, it's working. The title is changed to Welcome to NGINX again, and so has the header. By the way, if you want to see how many resources a node requires, you can click on the Add Nodes button, then hover over the node to see how many resources it requires. For nodes that are already in your topology, you can left-click the node, then next to the node name, hover over the blue eye to see how many resources it requires. We can see that it has a maximum of 10 interfaces. We will need to add a high availability link between FTDv0 and FTDv1 for our HA pair. It's recommended to add a direct link, so we'll do that. If you click on the Interfaces tab, however, all of our interfaces are used except for the Do Not Use one. So we need to either add 4 interfaces, or if you right-click the node and select Add Link, it will automatically add the interface that you select here. So I'm using G02. Click Create Link. Then if we left-click it and select the Interfaces tab, you can see it's automatically added that interface for us. Next, let's start our FTDs and FMC. You may want to stagger them so they don't overwhelm your server or PC. Okay, the FTD took about 5 minutes to start, and the FMC took about 10 to 15 minutes. Your experience may vary. One thing to note with the FMC is that it sort of got stuck on the circular arrow stage. So I right-clicked it and consoled in, and you press enter a few times, and then it should move to this green checkmark stage. So first, we're going to need to configure host names and management IPs on the FTDs. So you right-click them, console into FTDv0. The username is admin. The password is capital C, lowercase I, S, C, 0, 1, at 3. Use this command to configure its management IP. Then you have the net mask, and then the default gateway will be 192.168.1.1. That's shown in the diagram here. And press enter. Then console into FTDv1. Same username and password. And same command. Manual means static. In our diagram, we gave it 119, so that's what we'll use here, /24, and the default gateway is 22.168.1.1. So the default gateway will be pointing to the primary FTD. This is our standby FTD. You should get a confirmation that your network settings have changed. We'll also change the host name. So this is FTDv0. In FTDv1, we'll also configure the host name. And you can use the show network command to confirm your changes. So here's the new host name for FTDv0 and the IP address. Let's check on FTDv1. Host name and the management IP is good. I also wanted to demonstrate that you can access the FTD GUI or the FDM Firewall Device Manager from a browser. So if we right-click our Chrome node and then select VNC, open VNC, that's an old session. Then we go to the management IP of one of our FTDs. We'll use FTDv0. Again, it needs to be HTTPS. Click Advanced and proceed. This is just to show that you can access it. I'm not actually going to log in. The reason I'll show this is that this is pre-registration to the FMC. Once we register these devices to the FMC, you will not be able to access them you will not be able to access their individual GUI or FDM Firewall Device Manager because they will be managed by the FMC. So all configuration will be performed on FMC. Speaking of FMC, let's configure its basic settings. So let's right-click it, console in. The default username and password are the same as for the FTD. Then once you get to this caret symbol, it's a little bit different from the FDMs. or from the FTDs. So you'll need to configure it in the Linux shell, and to access that you type expert. And it might ask you for your password again. Then we'll set the management IP with this command. Then it asks for your password. We do wish to configure IPv4, so press Y. The management IP will be 192.168.1.120. That's what we called it in our diagram. The net mask is /24, that's correct. And its default gateway will be the FTDv 0. So that's 192.168.1.1. It asks you to confirm, type Y. Do you wish to configure IPv6? No. Okay, mine took about 2 minutes to display all of these messages, update network configuration, and then the comms channel configuration. It took a little while. Next, we need to get into the GUI of the FMC. So we'll open a new tab in Chrome, HTTPS. Advanced. Ignore this warning because it is a self-signed certificate in our lab. The username is admin. The password is the same password as before. The way I set up my network is that because the Chrome browser is, and because the FMC and the management IPs for it are in this subnet that is not my home network, I can't use my computer browser to access the GUI. I have to use the Chrome browser that's in the same subnet because there is no connectivity between the 10.0 subnet and the 192 subnet yet. We haven't configured the firewalls. Another tip for using the VNC within CML is that you can right-click the title of the node and then click Open Full Screen. That makes it a lot easier to read. So in this part, we will click the Start 90-day evaluation period without registration and click Save. Next, let's click the gear icon in the top right, then click Configuration. We should set the host name of the FMC. So it's FMCv-0. Click Save. In this same menu, scroll down to the bottom and Web Analytics. And we will uncheck this box because it's telemetry and this is just a lab. We don't need to be sending that data to Cisco. Go to Policies on the left, then click Access Control. Click New Policy. We'll call it Allow All. Select the default action to be Intrusion Prevention. Click Save. Then we don't need to add a rule. We can actually leave it without rules, but at the bottom, we'll change the default action to Trust All Traffic. This is just a warning saying that we can improve the performance of the FTDs if we change this setting, but we don't need to worry about it because it's just a lab. So ignore that warning. Click Save. Next, we need to register the FTDs with the FMC. So in the left pane, click Devices, then Device Management. Then in the top right, click Add Device. You need to use the IP address because we haven't registered the IPs to a host name in a DNS server yet. So the first one will be the management of IP of FTDv 0. We'll change its display name to be that so we can identify it more easily. Registration key is something that you make up. It's basically like a shared password between the FTD and the FMC for registration. So I use Cisco 123. Of course, in reality, in production, you should use something more secure. Then the access control policy is the one we created earlier, which is allow all. Smart licensing, you can just select 100 meg and check all the boxes in case you want to experiment with them. Transfer packets means that when certain connection events trigger, the FTDs will transfer the packets to the FMC for further analysis, which also generates more traffic. We can just leave it on since it's a lab. Click Register. Then when it's registering, you need to go into the CLI of FTDv0 and enter this command. Configure manager add, then the FMC management IP, and the registration key you just made. And press enter. This just is asking you to ensure that you've disabled any licenses you had on the FTD, or else the licenses will be still active on the device. So you can just type yes here, since we didn't actually activate any licenses on the FTD. So on the FTD, after about 10 to 20 seconds, it came up with these messages, and the local manager was deleted. That's good. That means that it can't be managed locally. And it's added this manager, which is our FMC. Now, if we go back to the FMC GUI, we can refresh this page, and you can see it's actually configuring. I'll change it to full screen. It's configuring this SF tunnel, which is short for source fire tunnel, which is a tunnel that the FTD and FMC establish for communication. Okay, after about 1 more minute, it came up with this green check mark, and FTDv0 is now registered. That's good. Now we should add FTDv1. So in the upper right, click Add Device. This time it's .119. The display name will be FTDv-1. We'll use the same registration key. Again, the same access control policy, 100 meg, and register. Now we need to go to the CLI of FTDv1 and enter the same command that we used on FTDv0. We do want to continue. Then we should check our FMC GUI. We'll right-click it and open full screen. Let's refresh this page. I'll keep this open so you can see all of the messages that show up, but I'll fast forward it. Let's refresh it. Okay, we are good to go. Now let's configure our HA pair. So in the top right, click Add, then High Availability. The name will just be FTDs. That's good. The primary peer will be FTDv0. The secondary or standby will be FTDv1. Continue. It will interrupt traffic. That's fine because there is no traffic. The high availability link in our diagram is G02. We need to give it an IP address. So we'll use a separate subnet that is its own unique subnet. So we'll say the interface is G02. The logical name will be HA for high availability. The IP address will be 172.16.0.1. The secondary IP will be 172.16.0.2. And the subnet mask will be /24. You can also make the subnet smaller just to conserve IPs, but since this is a lab, we don't really need to do that. The state link can just be the same as the high availability link. So if you click this dropdown, you can select same as LAN failover link, and it will replicate all of those settings. Then click Add. To clarify, the secondary IP will be on the standby. The primary IP will be on the primary, the active unit. Click Add. I'll fast forward this part. You can ignore any messages. These are trying to reach out, the FMC is trying to reach out to Cisco DNS and Talos via the internet, and it's not connected to the internet. So of course it's failing, so you can dismiss those. After a few minutes, FTDv0 came up with this warning indicating an error in communication on the HA link. I went into the CML topology, I stopped that link and started it back up. And after about 10 or 15 minutes, it finally came to the green check marks. So you may just need to wait a while for it to resolve its issues. Next, we need to add IP addresses to our FTD data interfaces. So from the devices page and device management, under the HA pair, click on FTDv0. It should take you to this page. If not, click the interfaces menu at the top. You can see gig 0 and gig 01 are both disabled because they don't have IP addresses yet. Let's add the IP address for the outside interface, gig 0. So in our diagram, it's 10.0.0.118, and it's in the DMZ, so it's the outside interface. We'll call it outside. Make sure you enable it. Leave the mode at none. The security zone, we need to add a new security zone. So we'll create the outside security zone. Then In the IPv4 tab at the top, we'll use a static IP. It will be 10.0.0.118/24. Click OK. Then we need to add an IP address for gig 01. We'll call it inside the security zone. We need to add a new one, which we will call inside. Then under the IPv4 tab, make sure you enable it. Then under the IPv4 tab, we'll give it an IP address of 192.168.1.1/24. Now we should click Save in the top right. And then up at the top menu, click Deploy All. Okay, that took about a minute. Then we should refresh this page to show that the interfaces should be up. And they're green, so that's good. Link status is up, that's good. Now, if we look at our diagram, I also assigned these IP addresses in the diagram. However, because this is an HA pair, only one of the FTDs will actually be active at any given time. So they actually will share these IP addresses, and only if FTDv0 has a link that goes down or the whole device goes down, then FTDv1 will take over as the active unit and start using these IP addresses to forward traffic. The reason I placed them in the diagram is that Cisco recommends to configure standby IP addresses for monitoring. So in the high availability tab, if you click that, then towards the middle of the page under monitored interfaces, we have our outside interface and the active IPv4 address. And we can click the pencil icon next to the outside interface and add a standby IP address. This is just good. It's best practice so that the devices can monitor based on IP and not only the link state. So we'll use 10.0.0.119 and the mask is a /24. Click OK. And we'll also add a standby to our standby FTD. So the standby IP address will be 192.168.1.2. Click OK, then click Save in the top right. Then we need to deploy our changes. Click Deploy All. Okay, before I forget, one more thing I wanted to show you is if we try to go back to the FDM or Firewall Device Manager of the primary FTD, it will not be able to connect. The reason for this is that, as I said before, it is now being managed by Firewall Management Center or FMC. So you cannot actually manage it using the management IP address anymore. You can only manage it from the FMC. Next, we need to set a default route on our data interface 10.0.0.118 to point to my home router, which is 10.0.0.1. So to do this, we click on the routing tab under devices, device management, and then you click on the FTD. Then click on the routing tab. Then static route in the left list, then add route. The interface will be the outside interface. This is the destination network that they're referring to. So any IP address quad 0 should be sending its traffic to my home router, which is 10.0.0.1. We use a metric of 1. That's good. Click OK. Click Save. Then we need to deploy the change. After our static route is deployed, we can do some testing. So we'll escape that. Then we'll test with a ping from FTDv0 to the home router, which is just a Netgear router, and we'll test it from the internet. So in FTDv0 CLI, ping 10.0.0.1, and that's good. What about the internet? That's also successful. That's good. Now let's do a test from FTD1 to my home router. That's successful because it's using the standby IP address. Let's test to the internet. And that's also successful. That's good. Let's do a test from internal server to DMZ server and from DMZ server to internal server to make sure the firewall is permitting that traffic. That's successful. That's good. And in the other direction, it's also going through. That's good. However, there is one issue that I haven't shown yet, and the FMC is actually not connected to the internet. None of the devices on this subnet are connected to the internet. That's because my home router is a simple Netgear router, which is only performing NAT for the 10.0.0.0/24 subnet. It is not NATing the 192 subnet. So in order to remedy this situation, we can perform NAT at our firewall, FTDv0. So we can configure that now in our browser. Under the Devices menu, click on NAT, then click New Policy. We'll call it Inside Outside and Outside Inside. The targeted devices will be our FTDs, which is our HA pair. Click Save. Then we need to add rules. You can add multiple rules to a policy. So our first rule will be a manual NAT rule, and it will be dynamic. The source will be from the inside. The destination will be to the outside subnet or security zone. The translation will be from the original source of any IPv4 address. We'll use the destination IP interface. If you read this information below it, it says the values selected for destination interface objects in the interface objects tab will be used. This is the interface objects tab over here. So the destination interface object is the outside interface, which is 10.0.0.118. So that means that anything from any IP address in the internal subnet, and actually we should make this more specific. It's better to be specific. We can use the 192 subnet. Anything from the 192 subnet will be translated. It will have its source translated to 10.0.0.118, which is the outside interface on FTD. So click OK. And let's add a second rule that will be a manual rule, but it's dynamic. It will be from the outside as the source and then to the inside. This will allow connectivity from our DMZ server to our internal subnet. Then the translation, the original source will be anything in the 10 subnet will be translated to the destination interface IP, which in this case is the inside interface. So in our diagram, that is 192.168.1.1. Looks good. Click OK. Then click Save. Then we'll deploy those changes. That took about 30 seconds for it to deploy. Then we can do some tests. So we'll close that for now. Then from our FMCv, we can ping my home router. And that's successful. That's good. Let's try pinging to Cloudflare DNS. That's successful. That's good. This will also get rid of all of these pesky warning messages about how it cannot reach Talos and it cannot reach AMP and DNS and all of those things, right? Because now it can reach the internet. Let's also do a test from the internal server to the internet, make sure that can connect. And it's successful, that's good. We can check our NAT translations on FTDv0 by using the show xlate command. So we've got ICMPs and we've got some UDP as well. These are UDP NTP requests because it uses port 123. Here's our ping, the ICMP from the internal server is being translated to this outside source IP. Let's do a ping from the DMZ server to the internal server. And we should see a translation entry as well in our FTD. Here it is. 10.0.0.130 is being translated to 192.168.1.1. Now that we have connectivity to the internet, that means I can also connect to the FMCv via my PC. But first, we need to go into Windows Firewall. So type Firewall in your Start menu. Then click Allow an app through Firewall. Type V to go down to Virtual Machine Monitoring. You need to change these settings. Normally it's disabled. I already had mine enabled, but we need to check it on the left to enable it. Select Private and Public. Click OK. Then close that. And now you should be able to ping your VMs from your PC. So I will try accessing the FMC GUI from my PC. And it defaults to HTTP, so we need to add an S here. And we can ignore the security risk because it's a self-signed certificate. Accept the risk and continue. And now we can log into the FMC. We can end the existing session. This should be a little bit easier to see. And it is, so that's good. Let's check on our HA pair. They are looking good. Now that we've set up our FTD HA pair, let's turn on logging. It would be nice to be able to see some of the connection events that we've just tested, but if you go into Analysis, Unified Events, it comes up empty because we haven't set logging in our policy. So in the left pane, click Policies, then Access Control. Then click the pencil icon next to the policy. Then at the bottom, we will keep it the default action as trust all traffic, but there's a cog icon next to it. So click it and check log at the beginning of the connection. We'll send the events to FMC because we don't have a syslog or SNMP server. Click apply, then save. There's a warning here. If we click analyze and then show policy warnings, this is the same warning as before. It's saying there are no rules configured, so we can improve performance by changing this setting. We can ignore this. So when we click deploy all, it comes up with this warning again. Click ignore warnings, then deploy. Okay, mine took about 30 seconds to deploy that change. Then we will go and do some tests again from our devices. So we'll ping from the internal server. I'll clear that. Ping from the internal server to the external server, or the DMZ. So we'll ping from here to the DMZ server. We'll just do 4 pings. That's good. Let's go back to our FMC GUI, analysis, unified events. And we can see these ICMP echo requests. So we've got some of those showing up. Maybe if we refresh it, it'll show the rest of them. There you go. Okay, so we've got our echo requests from the internal server to the external server to the DMZ server. Then we've got a whole bunch of other connections going on. Most of these are from my PC, which is 10.0.0.62, to the FMC, and they're TCP over HTTPS. That's because we're using my PC to manage the FMC. So that's what we're seeing here. Then we've also got some other connections. Here is a DNS request from the FMC out to, this is Cisco's DNS server. We've got an NTP request from the FMC to this NTP server. So you can see it actually generates quite a lot of logs. If I refresh this, there will be even more. And this is just a lab, but in a production environment, you would have way more logs than this. So when you do the connection, when you do the log at beginning of connection in your policy, you may want to limit it to certain rules instead of all traffic like we did. Okay, now that our monitoring is set up in FMC, I also wanted to do a packet capture on the FTDv0, which is our active. So from the CLI, you can use this command, capture, then the name of your capture. We'll call it pings, all uppercase. Use the interface. We'll use the outside interface. And we'll match ICMP from anywhere to anywhere. So what we're going to do next is test our FTD HA failover function. So we're actually going to disable this link G00 while we're pinging from DMZ server to the internal server. So we'll run a packet capture, and we have logging turned on our FMC. So we should be able to get some good data when we do this test. If you do show capture, you can see your active packet capture. So this one says it's capturing right now, so it's waiting. So we'll run our test now. So first, I need to ping from DMZ server to the internal server. Once that ping is going, we'll go ahead and shut down this link. We'll see a brief interruption in these pings. So we'll right-click G00, click disconnect. And you can see the pings have stopped. Now they resumed again. So a very short interruption. Then let's go to our FMC. We can see the warning message. The HA link has failed. So that's good. That's what we're expecting. Interface G00 has no link. That's good. We can dismiss these. Then let's go to our devices, device management. And we can see the secondary FTD or FTDv1, the standby, is actually now our active. So it is forwarding traffic. You can see it from here, and you can also see it in the cog icon, and then health under this health menu monitor. And we can see it here as well. So it says FTDv0 has failed, and FTDv1 is our active. Let's go ahead and we still have our pings running. That's good. Let's go ahead and reactivate this interface. We'll right-click it, click connect. By the way, you can't use stop. I found that doesn't cause a failover. It just black holes the traffic. It will just keep sending it here, and the device, the firewall will not fail over. So you need to use this disconnect or connect option. Now let's check our FTD pings, or our pings from DMZ server to internal server are still going. That's good. They are still using the standby FTD. If we go back to our FMC and then devices, device management, this may take a while. While we're waiting for FTDv0 to show as green again, we can go ahead and stop the ping from the DMZ server to the internal server, and we can stop the packet capture on FTDv0. That's because since the failover, DMZ servers pings are now going through FTDv1 instead of through FTDv0. So we don't need to run this packet capture anymore. To stop a packet capture on FTD, you just press Control-C. Then let's do show capture. It still says it's capturing, so we need to stop it. That didn't work. Stop. Capture pings stop is the command, not Control-C. So let's check it again. Now it's stopped. Let's go ahead and view that. So we'll say show capture pings. And it's showing the 26 packets. So presumably that's the reason there's only 26 packets, even though we ran way more pings than that. Oh, about 100, about 200 pings, almost 200 pings. So the pings kept going because they were going through FTDv1. So that's why our capture on FTDv0 only shows 26 packets. Okay, in FMC, mine took about 10 or 15 minutes to return to its previous state. However, you'll notice FTDv0 is the primary, but it's still in standby mode. And FTDv1, even though it's secondary, is still active. That's because FTDs do not use preemption. Preemption means that the primary reverts or resumes the active role when it comes back online. FTDs do not do this by default. If we want, we can force them to change roles by clicking the More Actions icon. There's 3 dots right here next to the pencil, next to the HA pair. And then we can select Switch Active Peer. And we can click Yes, and they should switch. Mine took about 5 or 10 minutes to switch back and turn green again. Your experience may vary. Let's go ahead and clean up that packet capture. Since we're done using it on FTDv0, you can delete a packet capture with this command, no packet capture, or no capture, and then the name of it. It was called pings, all caps. Then if we do show capture, it comes up blank. So that means we've removed it from the FTD, so that's good. Then let's check our logs again under Analysis, Unified Events. By the way, an FMC can store millions of logs. Usually it stores 10 million, but it can store up to 50 million. So in our case, we obviously don't need to worry about that, but just an FYI. So here are our logs. Now I'm going to shrink this, move these columns over a little bit so that we can see more information. They also don't have anything in these columns. Okay, so we'll see if you scroll over to the right, it shows you which FTD was processing the connection. So using this information, we can actually see where our pings were and what happened. So here's our last ping from the DMZ server to the internal server. And that was processed on FTDv0. Then the next ping, this is where it failed over, was processed on same source and destination, was processed on FTDv1. So we know our failover occurred at this point in time. And we even have a nice timestamp to see when it happened. Then if you keep scrolling up, we can actually see when we restored FTDv0 to the active role. So it's right here around this time. We weren't running any pings at the time, so it's a little bit harder to see the exact time. By the way, one thing you can do is you can click this column icon in the top right, and you can add or remove columns. So in our case, or in my case, we can see that the reason column is empty, so we'll remove that since it's just in the way. Then we'll also add, I like to add the NAT destination IP and the NAT source IP. So if we click apply, then we should see everything is trust, of course, so we could also remove that column if we wanted. But if we scroll to the right, actually I would probably reverse these columns. That's a little bit weird that it put them in that order. Maybe we can change it here. There we go. Swap the order. So the NAT source is always here and the NAT destination is here. And you can see that it's always, the NAT source is always either the FTDv0 or the FTD inside interface, 192.168.1.1, or it's the outside interface, 10.0.0.118. It's always that for the NAT source IP. That's because of the way I set up NAT on my lab. Okay. Now, one thing I also wanted to show you guys was how to do an upgrade. So I actually can't show you this because I don't have any other firmware versions for these FTDs that I can upload because I don't have a Cisco contract. Essentially what would happen in the process for it is that FTDv1 is our standby right now. We would perform an upgrade on it. That does not impact traffic flow because it is not currently processing traffic. Once it's upgraded, we would perform a failover from FTDv0. We would upgrade FTDv0, and when it upgrades, it will fail over to FTDv1 so that there will be very little or no traffic loss. Then after FTDv0 is upgraded, we can as we did earlier, we can swap roles so that the FTDv0 becomes the primary again. By the way, if you want to filter your FMC event messages, you can, let's say I don't like how many TCP 443 messages are coming in, and they're all just my management session to the FMC. So we can filter those out. If you go to the message or the port that you want to filter out, so let's say we don't want to see these destination to 443 HTTPS. In this column, if you go over one of those entries and click on Add Exclusion to Filter, it will add this filter at the top. Exclamation mark means not 443. Click Apply. And now we don't have those messages. So it's a little bit easier to find the important things that we're looking for. For example, our pings. Alternatively, you could also, if you don't want to have those logs show up at all, you could go into the policy, access control, edit the policy, then add rule. We'll call it allow management to FMC do not log. So this will, the action will be allow. We will not turn on logging. The zone will be from the outside zone. So the 10.0.0.0/24 subnet. The destination zone will be the inside zone. And we'll make it more specific. So we'll use this network. The network will be, actually we'll add a network object. The object will be network, but it'll be a host. The name will be FMC. The host IP is 192.168.1.120. That's our management IP for the FMC. Click Save. That will be our destination network. And the port will be, destination port will be HTTPS. You have to press enter here. We'll add the destination port. And we'll click apply and save. Then deploy all. Please note, in a production network, you would want to log connections to your FMC. This is just an example of how you can decrease your logs. Mine took about 20 seconds to deploy that change. Then under analysis, we'll go to unified events. Now we have a whole bunch of events still. If you ever want to clear your events, you click the cog or the gear icon in the top right. Then under the tools menu, go to data purge. And we can remove these events. We'll select these connection events and these other ones. We'll purge the selected events, click OK. It takes it a minute. Okay, after it shows this message, we'll go back to our unified events under analysis. And we've only got a couple now. So these are our UDP DNS calls from DNS requests from the FMC to Cisco's DNS server. Let's do some pings to see if we can get some more connection events. We'll ping from the DMZ server to the internal server. then go back to the FMC GUI. Okay, to get mine to refresh, I actually had to navigate away from this page. So I went to my access control policy and then I came back to unified events and it updated. So we can see those pings from the DMZ server to the internal server. And we do not have any connections to HTTPS of our FMC with the destination of our FMC. However, we do have this connection from our FMC to this IP address using HTTPS. I'm not sure what this IP address is, 192.111.4.180. So if I hover over the three dots next to the destination IP, I can click it and then select who is. And it shows this information. So this is actually owned by Cisco Security. And here it says Cisco AMP operations. So this is their advanced malware protection. So it must be reaching out. I think FMC is reaching out to the Cisco AMP server, which it's supposed to do periodically. So that's good. We've seen what happens if a member of an FTD HA pair goes down. But what happens if your FMC is disconnected? If that happens, the firewalls continue processing traffic and functioning as an HA pair. The only difference is you cannot make configuration changes. Additionally, Active Directory will be disconnected if it was integrated with your FMC. Active Directory cannot integrate directly with an FTD. We'll do a quick demonstration of what happens when the FMC is disconnected. So in our lab, we will begin a ping from DMZ server to the internal server. We'll just let that run. Then on the link from the unmanaged switch 1 to the FMCv 0, we will right-click it and select disconnect, then go back to our pings, and we see there was no interruption. We can also try to connect to the FMC GUI, and it will be unsuccessful. So it's timing out here. We can also try it from our Chrome VNC. That's an old session. And it's timing out here as well. Additionally, we can try to connect to the FTDv0 management interface. But as you can see, this is also unsuccessful. So the only way we'll be able to manage our FTDs again is if we get the link to the FMC up again. So we will right-click it, then connect. Then let's try refreshing our management session. And that's successful. That's good. You can also configure FMCs in a high availability pair if you want to make sure you never lose the ability to configure them. That's the end of this lab. I hope it was helpful and you learned something about configuring FTDVs in a high availability pair using FMCv. I also hope you learned a little bit about basic access control policies and unified events management.